Here is something nobody tells you. Right now, the most complex object in the known universe is sitting on your shoulders. And somewhere out there, billions of light years away, is the most destructive force the universe has ever produced. One creates, one destroys, one holds memories, one holds nothing, not even light. And for centuries, scientists have studied both of these things separately. But what happens when you put them side by side? Before we dive in, I want to ask you 3 questions, and I want you to hold on to them. Question 1, can your brain store more information than a black hole? Question 2, which one distorts reality more? The gravity of a black hole or the imagination of a human mind? And question 3, the one that will keep you up at night. What if black holes and brains are not opposites at all? What if they are the same thing? By the end of this video, you will see both of these objects in a completely different way. Because here is the twist nobody saw coming. The most powerful force in the universe might not be gravity. It might be the thing that can imagine gravity. But we are getting ahead of ourselves. Let us start at the edge of the most terrifying thing in existence. Picture a star, not just any star. A star 20 times bigger than our sun. It burns for millions of years. Hydrogen, helium, carbon, oxygen, iron, each one fuse in its core like a nuclear engine the size of a solar system. And then one day it runs out of fuel. The engine stops. And everything that was pushing outward for millions of years suddenly has nothing to fight against. So gravity wins. In less than a second, the core collapses. We are talking about something more massive than the sun, compressed to the size of a city, then smaller, a mountain, a building, a marble, and it does not stop. The math says it keeps going, collapsing forever until it becomes a point of infinite density, a singularity. Let that word sit for a second. Infinite density. That means everything that was crushed into a point smaller than an atom. No size, no volume, just mass. Pure, horrifying mass. And around that singularity sits what we call the event horizon. Now here's where it gets wild. The event horizon is not a wall. It is not a surface you could touch. It is a boundary, an invisible line in space. Cross it, and you can never come back. Not because anything holds you, but because space itself is flowing inward faster than the speed of light. Think about it like a river. You are swimming upstream. You are a fast swimmer. You can fight the current. But as you approach a waterfall, the water starts moving faster than you can swim. At some point, it does not matter how hard you try. The river wins. That is the event horizon. Past that line, even light, the fastest thing in existence, gets pulled in and never escapes. And here's a fact that honestly broke my brain the first time I heard it. At the event horizon, time slows down, not metaphorically, literally. If you were falling into a black hole and somehow survived, you would see the entire future of the universe play out in what feels like seconds to you. Stars would be born and die. Galaxies would form and collide. The sun would expand and swallow the earth. And to you, watching from the event horizon, it would look like a fast-forward film, because near extreme gravity, time is not a constant. It is a variable. Einstein told us this. Black holes proved it. Now let us talk about size. Because black holes are not all the same. Stellar black holes, the ones made from dying stars, are relatively small, roughly 10 to 24 kilometers across at the singularity. But supermassive black holes are something else entirely. At the center of most galaxies, including ours, sits something almost incomprehensible. The black hole at the center of the Milky Way, called Sagittarius A star, has a mass 4 million times that of our sun, for million suns, and it is 26,000 light years away, which sounds safe. But here's the thing most people do not realize. We are orbiting it right now. Every 226 million years, our entire solar system completes one lap around that monster. But even Sagittarius A star is not the biggest. The black hole at the center of galaxy M87, the one scientists photographed for the first time in 2019, has a mass of 6.5 billion suns. Its event horizon is bigger than our entire solar system. You could fit Neptune's orbit inside it with room to spare, a thing that fits inside a single galaxy. And it is bigger than everything we have ever called home. But here's the crazy part. Black holes do not actually suck. Gravity does not suck. It curves. Imagine a heavy bowling ball placed on a stretched rubber sheet. It creates a dip. Other objects roll toward it. That is what mass does to space. A black hole just does it so extremely that the dip becomes a funnel. And the funnel becomes a point of no return. One more thing about black holes before we move on. They are not just destroyers. Some scientists believe black holes are the universe's way of recycling. They consume matter. They radiate energy slowly through something called Hawking radiation, named after Stephen Hawking, who theorized it in 1974. The idea is that even black holes eventually evaporate. They lose energy over billions and billions of years, until they just disappear, like a cosmic exhale. But what happens to everything they swallowed? Where does the information go? Hold that question. It matters more than you think. Now let us zoom in on something 26,000 light years closer. Something you have been carrying around your whole life without ever truly seeing it. The human brain. It weighs about 1.4 kilograms. The consistency of firm jelly. It uses roughly 20 watts of power, about the same as a very dim light bulb. And yet, right now, while you watch this video, your brain is processing millions of signals every second. It is regulating your heartbeat, managing your breathing, translating sound waves into words, forming memories, running background emotional checks, and somehow managing to notice that notification sound you just heard. All at once, without trying. The brain is made of neurons, about 86 billion of them. Now that number sounds big, but what matters more than the neurons is what is between them. Synapses. Each neuron can connect to up to 10,000 others. Do the math. That is roughly 100 trillion connections in a single human brain. 100 trillion. For comparison, the Milky Way has about 400 billion stars. Your brain has 250 times more connections than our galaxy has stars. Let that compete with a black hole for a moment. Now, what does the brain actually do with all those connections? Information. Everything is information. When you see a color, that is neurons firing a pattern. When you feel pain, that is neurons firing in a different pattern. When you remember your first bike ride, that memory is literally a physical structure in your brain. Proteins, chemicals, a pattern of connected neurons that was built when the experience happened. And here is something that still confuses neuroscientists. We do not fully understand how memories form. We know the general process. But why some memories stick and others vanish? Why trauma can rewrite your entire personality? Why a song from 20 years ago can put you right back in a specific moment? We do not fully know. The brain has a dark side, not in the evil sense, but in the unknown sense. Large portions of what happens in there we cannot observe, cannot measure, cannot explain. But here is what we can measure. Storage capacity. Scientists estimate the human brain can hold about 2.5 petabytes of information. 1 petabyte is 1 million gigabytes. So 2.5 petabytes means, if your brain were a smartphone, it could hold 3 million hours of high-definition video. That is 340 years of content without repeating a single second. And you're walking around with that in your skull right now. But it gets stranger. That storage capacity is not fixed. Your brain physically rewires itself based on experience. This is called neuroplasticity. Every time you learn something, your brain literally changes shape. New connections form. Old and used ones get pruned away, like a garden. The brain you had at 10 is structurally different from the brain you have now. The brain you will have at 70 will be different again. You are, in a very real sense, a different person every decade. And your brain is the physical record of that transformation. The brain can process visual information in as little as 13 milliseconds, faster than a camera, faster than most computers. And its pattern recognition is unmatched. You can recognize a face in a crowd of 1,000 people almost instantly. You can hear someone call your name across a noisy room and immediately locate the source. No supercomputer on Earth, not any artificial intelligence we have ever built, can do all of this simultaneously with 20 watts of power. But here is the real question, the one this whole video is building toward. We have a black hole, the most extreme gravitational force in the universe. And we have a human brain, the most complex information processor ever discovered. What do they actually have in common? Because they have more in common than anyone expected. In 2020, researchers made a discovery that sent the scientific community into a quiet frenzy when they compared the large-scale structure of the universe, the cosmic web of galaxies and filaments, with the microscopic structure of the human brain. They found something deeply uncomfortable. They looked almost identical. Same clustering patterns, same filament structures, same ratios of dense nodes to empty voids. Now, this does not mean the universe is a brain, or that your brain is a universe, but it means something profound. Complexity, at every scale, organizes the same way. Nature has a favorite shape, and it uses it from the smallest neuron to the largest galaxy. But let us go deeper. Both black holes and brains are black boxes. We have studied black holes for over a century. We have imaged them, measured their effects, watched them consume stars, and we still have almost no idea what happens inside one. The singularity breaks every equation we have. Physics, as we know it, stops working past the event horizon. The brain, same story. We have done brain scans. We have mapped connectivity. We have measured electrical activity. And we still do not know how consciousness happens. We do not know how the physical structure of neurons creates the subjective feeling of being you, how you feel love, how you experience awe, how you can sit here and wonder about a black hole. Both objects are known from the outside only. The inside remain for now a mystery. Both also store information in ways we do not understand. When something falls into a black hole, the information it carries, its arrangement of atoms, its quantum state, everything that made it what it was, seems to vanish. This is called the information paradox, because physics says information cannot be destroyed. It is one of the foundational laws of quantum mechanics. So where does it go? One leading theory says the information might be encoded on the surface of the event horizon, like a hologram. The three-dimensional object falls in. Its two-dimensional shadow stays on the edge of the hole, encoded in radiation. Now here's where the brain enters. Memory in the human brain is not stored in one place. It is distributed. A single memory might be encoded across hundreds of thousands of neurons, a pattern, not a location. You can damage a brain and lose specific functions, but you rarely lose a single isolated memory, because memories, like the information at a black hole's horizon, are spread across the surface. Same solution, different scale. Both also warp perception. A black hole warps space-time. It literally bends the fabric of reality. Time runs slower near one. Space curves around one. Your brain does something eerily similar, but to perception. Your brain constructs reality. What you see right now is not raw data. It is a model built by your brain, 1/10 of a second behind actual time, filled with predictions and assumptions and emotional color. You do not see the world as it is. You see the world as your brain predicts it is. People who have had strokes in specific brain regions have stopped being able to see the left side of the world entirely. Not because the light was not there, because the brain stopped modeling it. One warps physical space-time. One warps experiential space-time. Both make reality negotiable, and both reach the limits of human understanding. The equations that govern black holes break down at the singularity. Math gives us an infinite answer. And infinity, in physics, means our model is wrong. The equations that govern the brain break down at consciousness. We can describe every neuron firing, but we cannot explain why there is something it feels like to be you. This is what philosopher David Chalmers calls the hard problem of consciousness. It is the singularity of the mind. Both objects have a point at the center where understanding collapses. But for all their similarities, these two things are also opposites in the most dramatic way possible. And the differences tell us something deep about what power actually means. A black hole, by all appearances, is the universe's greatest eraser. Everything that falls in stars, planets, people, memories, books, music, gone. The brain does the opposite. It takes raw sensation, photons, pressure waves, chemical signals, and creates information from them. It builds meaning where none exists. You look at clouds and see faces. You hear random notes and find melody. You read these words and experience ideas. The brain is a meaning-making machine. One is the universe's most powerful delete key. The other is the universe's most powerful author. Nothing escapes a black hole. Not matter, not radiation, not light. The human brain, on the other hand, invented the light bulb. It created lasers, fiber optics, the screen you are watching this on right now. More poetically, the brain creates inner light, creativity, inspiration, the sudden flash of a solution to a problem you have been stuck on for weeks. Neuroscientists can literally see this. A moment of insight shows up on a brain scan as a burst of gamma waves, a literal flash of electrical activity in the right temporal lobe. Your aha moment has a brainwave signature. That is your brain creating light in the dark. A supermassive black hole can disrupt the orbit of entire star systems, consume hundreds of stars per year, but a single human brain, using 20 watts of power, produced the atomic bomb, the theory, the engineering, the terrible, terrifying outcome, which is more destructive, the force that swallows stars silently over millions of years, or the 3-pound organ that figured out how to split atoms and did it in less than a decade. Power is not just raw force. Power is leverage. And a brain that can harness forces bigger than itself might be the most powerful thing in existence. Now we get to the part where things get beautifully, uncomfortably strange. Physicist Juan Meldacena proposed something in 1997 that physicists are still arguing about today. What if the universe is a hologram? What if everything we experience in 3 dimensions, space, time, gravity, matter, is actually encoded on a 2-dimensional surface? Like how a black hole encodes its swallowed information on the event horizon. What if the entire universe is doing the same thing? Every atom, every star, you, me, this video, all of it, a projection from a flat surface, somewhere at the edge of reality. This is not science fiction. It is a mathematically coherent theory tested and expanded by thousands of physicists. And if it is true, your brain and a black hole might both be reading from the same source code. Some cosmologists have also proposed, with actual mathematics to support it, that the universe behaves like a learning system. The cosmic web has nodes and connections. Information flows between galaxy clusters along filaments. The whole structure optimizes over time, just like a neural network being trained. If true, black holes might be the universe's neurons, dense processing nodes that receive input, transform it, and radiate output. We could be neurons in a universe-scale brain. And black holes could be the most active, densest synapses. Nobel laureate physicist Roger Penrose proposed something even more radical. Consciousness, he said, might not be just a product of classical computation. It might arise from quantum processes in the brain, specifically in structures called microtubules inside neurons. And quantum effects, superposition, entanglement, wave function collapse are also the language that governs what happens inside black holes. If consciousness is quantum and black holes are quantum, then maybe the 2 most mysterious things in the universe are speaking the same language. We just have not learned to translate it yet. Here is the part one have been building toward the entire time. A black hole is powerful, undeniably, extraordinarily, cosmically powerful. It bends time. It breaks physics. It swallows light. But here's a question nobody asks. Does the black hole know it is powerful? Does the event horizon know that it traps light? Does the singularity know that it crushes matter? Does the black hole know, in any sense of the word, that it exists? No, it does not. A black hole is the most powerful object in the universe. But an object has no experience of its own power, no awareness, no wonder, no fear, no awe. Now think about what your brain just did in the last 27 minutes. It traveled 26,000 light years to the center of the Milky Way. It compressed billions of years of cosmic history into comprehensible thought. It felt something when it imagined a star dying. It connected emotionally and intellectually with an object that would destroy it without a second thought. Your brain imagined the black hole, studied it, named it, photographed it, built theories about it, wrote poems about it. The black hole has never once thought about you. Which one is more powerful? The thing that bends space-time, or the thing that can understand space-time and then wonder what it means? The black hole consumes everything and knows nothing. The brain creates meaning out of nothing and then asks if there is more. That is not just power. That is something the universe has never produced before. At least, not that we know of. We started this video with a question. Which is more powerful? A black hole or human brain? And I think you already know the answer is not simple. A black hole wins on force, on scale, on destruction, on sheer raw, physical dominance of everything around it. But a brain, your brain, wins on something harder to measure. Awareness, curiosity, the ability to hold an image of the entire universe inside 3 pounds of tissue, the ability to feel small and keep asking questions anyway. Carl Sagan once said, "We are a way for the cosmos to know itself." And I think that is the answer. Black holes are the universe's most extreme force. But you, sitting here, watching this, thinking these thoughts, you are the universe's most extreme achievement. Because the universe created something that can look back at itself, that can find a black hole 55 million light years away, stare at it, and say, "I see you." We have spent centuries looking outward, scanning the sky for something more powerful than us, something bigger, something more dramatic. But maybe the most dramatic thing that has ever happened in this universe is that it became conscious. And that happened not in a black hole, not in the heart of a dying star. It happened inside a skull, inside a soft, gray, 20-watt organ that still surprises us every decade. You've spent your whole life looking up at space. But the most mysterious space in the universe has always been right here,